Okay, so we are doing 2.7, finding the inverse of a matrix. Last time we had the definition. It's about the inverse, right? So we have square matrix for A, then A has inverse. If only if this one satisfied, right? So A has inverse of A equal to A inverse of A times A equal to identity matrix, which is the same size n by n. Then we can say that the matrix A is invertible. And then I want to add one more thing here. If A is 2 by 2, we can check that whether A is invertible or not. So let me write down. If A is 2 by 2, and A equal to A, B, C, D, I believe, then AD minus BC is not equal to 0, then A is invertible. So in other words, AD minus BC equal to 0, then A is not invertible, right? Means that otherwise AD minus BC equal to 0, right? Okay, let us do this one. So we're gonna find matrix so we have A equal to 1, 1, 1, 2. In order to find the inverse, of A, and find X, Y, Z, W, such that, okay, so if we multiply, if in that case is the inverse, then we multiply A and inverse, we get the identity, right? So I'm gonna write down. So 1, 1, 1, 2, X, Y, ZW equal to, since 2 by 2, we can have a 2 by 2 identity, which is 1, 0, 0, 1, right? Okay, let's check the whether A is invertible or not. Check it out. Check. So AD minus BC is not equal to 0. Okay, AD, in that case, AD, which is 1 times 2 minus B times C. So we get 2 minus 1, which is 1, is not 0. So A is invertible, right? Is okay? All right, let us do this. So we multiply. So we multiply this way, right? So multiply this. Okay, we will get 1 times X plus 1 times Y. And we get 1 times x plus 2 times y. Now, we have first row, second column, so we get 1 times z plus 1 times w. Then we get 1 times z plus 2 times w, right? Okay, so we get other size identity matrix. Okay, this will be xy, x plus y, x plus 2y, and z plus w, z plus 2w, right? 1, 0, 0, 1. Okay, we have 2 by 2, 2 by 2, so this one corresponding that, this one corresponding that, this one corresponding that, this one corresponding this, right? So let us write down. So this will be x plus y equal to 1, x plus 2y equal to 0. And then we have z plus w equal to 0, z plus 2w equal to 1, right? Okay, now let us work this one. This one? Okay, so we can write down augmented matrix 1, 1, 1, 2, 1, 0, right? Okay. We want to make 0 here. So basically, we're gonna make RREF. So we want to make 0 how? Equivalent. Equivalent.
We could subtract the top row from it.
Okay, -1 times the row number 1, row 1 plus
Uh-huh.
R2, right?
Yeah.
Okay, good. So row -1 plus R2, row 2, right? So 1, 1, 1, 0, 0. Okay, hold on 1 second, made a mistake. So that is -1, right? Okay, now it's done for the second row. How about this? We want to, we want to make a 0 here. How do you make a 0? Negative R2 plus R1 to make R1. So we get 1, 0, 2, 0, 1, -1. Very good. Thank you, direct message. Okay, then in that case, this one is X, this is Y, right? So first row says that X equal to 2. Second row says that Y equal to -1, right? Okay, now, how about this? So we are writing down augmented matrix, this one as well. So 1, 1, 1, 2, 0, 1. Okay, goal, RREF. Okay, now we want to make a 0, same strategy, right? Same procedure as earlier. So we want to make a 0 here. Same process. So negative R1 plus R2 make R2 replace, right? So we have 1, 1, 0, 0, negative 1, negative 1. Equivalent. Okay, now we want to make yeah, so we want to make a 0 here. Then we get just R2 plus R1, right? Let me see. The wrong message. Okay, let me see. I made a mistake. Oh, hold on one second. I click. Okay. Thank you, the wrong message. Let me check. Okay, I made a mistake there. R1, 0. Yeah, positive, correct. Yes, positive. Thank you, the wrong message. And positive as well, right? Good job. Okay, now. Okay, now we want to make a 0, then I cannot just add them because I don't have a negative. So we make negative R2 and R1. Yeah, to make R1. So 1, 0, negative 1 then. Yeah. Okay, 0, 1, 1. Okay, good job. So this will be Z, this will be W, right? So that means Z equal to negative 1, W equal to positive 1. Okay. Yeah. All right. Thank you. Direct message. Okay, now how do we write down? This is the inverse. So basically, we product of two matrices gives the identity. That means one is inverse, right? I mean, they are inverse each other, right? So this is A, we say that, and this is inverse, yeah, to get the identity, right? So by definition here, right? Okay, so we can conclude inverse of A, which is in that case X, Y, Z, W. That is, we have X equal to 2, Y equal to negative 1, Z equal to negative 1, W equal to 1, right? All right, very good. Okay, now, can you guys see that here? This is identity matrix, and then this is, we had the constant matrix, right? If we name this, right, constant matrix, but then this is also column matrix. So your book indicate that that will be I line and X column vector, right? And also looking at this one, we have identity. And also this is a constant matrix, right? So looks like this too. So they mentioned that this is identity, different color. I is identity. So X is column of inverse in that case. Okay, so we have I and X as well. Okay, so if we rewrite everything this one, we can say that this one, right? So we can say I, which is identity, 1, 0, 0, 1. We have X, Y, Z, W, which is 2, -1, -1, 1, right? Okay, so in that case, we can read I an inverse of A matrix, right? All right, now we can have definition of this. Let me write down. Matrix inverse algorithms. Algorithms. 2.7.1 matrix inverse algorithms. Okay, now suppose A equal to n by n square matrix, right? To find the inverse of A exists, if it exists, form the augmented matrix. So we have AI okay, we're gonna make IB to row operation until IB. So B is inverse of A and A is invertible, right? If it's impossible to row reduce, for a matrix of the form so basically we cannot make this form one side identity and other side the inverse, right? This is B is the inverse of A, right? Then we can say that A has no inverse. All right. So we start with the original matrix, and then other side we have identity matrix, right? And we keep the same size of matrix. Then we make a row operation to make identity from the matrix A. So we don't care anything about this. We just make here row operation. And then this one just follow same row operation with us, right? Here, right? Then that will be inverse of it, right? Okay, let us do this. If we cannot make reduce, so basically this is RREF same as, right? Reduce the row echelon form, right? So if we cannot make that, then there's no inverse. Okay, let us do this. So we're gonna do slowly because a lot of work. I don't want to make a mistake. Okay, we have let A equal to 113, 201, 221. Find inverse. So it exists. Yeah, this is a 3 by 3, so we can use like a 2 by 2, which is AD minus BC is not equal to 0, then A is invertible, right? Yeah, we cannot check that, but we have that. If we cannot make a reduced form of the matrix, right? Then there's no inverse, right? Okay. Let us do this. Let's do it. Ready? So we start with identity matrix is the other side. So A, that means we have A113, 201, 221, and other side has, right hand side we have identity matrix, which is the same size with the matrix A, right? So 3 by 3, so 1 0 0 0 1 0 0 0 1. Okay, so it will be equivalent with next one. Okay, let us make that. Always easy one, right? So make it 0 underneath first row, right? What do you think? One, two, two, 1 0 0. Negative R1. Make R2 to get R2. Thank you, direct message. Okay, so we get 0, negative 2, 0, and negative 1, 1, 0. Okay, let's make a 0 here. How do we make a 0? Thank you very much, direct message. So let us make a negative R1, negative 3, row 1, plus row 3 to get row 3, right? Negative 1, 0. So, okay, let's see. This is 0, negative 5, negative 7, negative 3, 0, 1. Please correct me if I make a mistake. Okay, now we want to make 0 here. Okay. Hold on 1 second. This one should be -5. Okay, let us do that. Oh, wait, what's going on here? 311, huh? Okay, all right. I think we're missing here. Maybe that's why you get confused. All right, thank you. Okay, we want to make a 0 there. Okay, then that is 5R2 plus -2 R3 to get R3. Is it correct? Yes? Okay. Let me. Okay, so there is mistake, -5. Yeah, so -3 times that and -5. Okay, now we want to make a 0, so 5 times R2 -2. Okay, so that is 0 for the first one, 0 for the second one. Third one is +10, 0, 0, +10. Okay, and we get 5 and -2, right? So there will be 5 and then -6, +6 is the +1, and then 5 and -2, correct? 1, 5, -2. Yes? Okay, now. We want to make identity, right? So this one easily to make identity. And this one make easily to make 1, right? Okay, now we want to make a 0 here.
Oh, should we just add row 2 to it?
Thank you. So we make R1 plus row 2. So 1, 0, 2, 0, 1, 0, right? Okay. All right, now we want to make is it better we make 1 then make a 0 there? So let's do that. Let's make 1 here. So 110 R3 to make R3. So we have 001. Oops, here is a fraction. I didn't think about that. So 1/2 and -1/5. Yeah. Okay, now we want to make a 0 here. So there will be -R3, 2, and R1 to make R1. So 0, 0, oh, 1, sorry about that, 1, 0, -2, which is, ooh, so -2, 110 plus 0, right? So that is -1/5, and then -2 R3, which is 1/2 plus 1, that is 1 is 0. Okay, all right, -2 R3, which is 1/5 plus 0, which is -2/5. Woo! Okay, now we can make 1 in the second row. So -1/2 R2 to make R2. So this is 0, 1, 0, +1/2, 0, 0, 0, 0, 1, 110, 1/2, -1/5. Yeah. Okay, now. Can you please check that? We got the different number. Where we make a mistake. Oh, you should have told me earlier. Yeah, when you see the mistake, you have to tell us immediately so that we can go down. I want to cry. We did a lot of work. -2/5 should be positive. Yeah. So direct message, this one? Ah, I went too fast. Okay, I'm very sorry. All right. Okay, please correct me now. That is correct, right? And then another dilemma said that this is a positive 2/5. Negative, this is come from -2 or 3. It's a positive, that's correct. Positive, yeah. Thank you. But then this is the last one still. Yeah, this is correct. 1, 5, -2, yes.
Hi,
Zero.
Professor Lee.
Uh-huh.
Yeah, so we checked that one because I got a little bit different. I didn't get 0, 0, 10. Yeah. So when you use 5 multiply R2, add on -2 multiply R3, what I get is, let me see, 1, 2, 2. 0, 0, 5. Okay. Yeah. Then now it's correct. Yeah.
Okay, so everything is correct. So
Yeah.
I copy wrong. So it's supposed to be 1 there. So it's supposed to be 1, not the 0. Okay. Supposed to be 1. And then what we do, we multiply by just -1/2, since 1 there, and then multiply by -1/2 is -1/2. Only this one is incorrect, so please fix that. Okay, yeah, good job. Woo. Okay, now we made IB, which is from AI, right? So B must be inverse of A, right? So this is inverse. We can just say that directly, which is -1/5, 1/2, 1/10, 0, -1/2, 1/2, 2/5. Thank you for fixing this one. During message 0, -1/5. So this. Okay. I copy wrong at first. Yeah, it's supposed to be -1, but it's okay 1. But we made it. All right. Okay. Let's do other one. How about this? So let A equal to 112, 202, and 224. Find inverse if it exists. Okay, let me do slow. Okay, so let us make it this way. 112, 202, 224. All right, identity 100010001. Okay, first up, always, right? Always make this one equal to 0, right? Equivalent. How do you make 0? R2 make R2, right? So 1, 1, 2, 2, 1, 0, 0, and 0, -2, 0, -1, 1, 0. Yeah. Okay. All right. How do you make a 0? Oop. That is negative row 1 plus R3, right? Row 3. So there will be 0, -4, 2, -4, -2, -4 is 0, right? Ah. And -2, yeah, -2, and -2, 0, 1. Okay. So we want to make a 0. Doesn't look good, right? Equivalent. Negative R row 2 plus R3 make, yeah, thank you. R3, 1, 0, 0, 0, negative 2, 0, negative 1, 1, 0. Okay. 0, 0, 0, negative positive, negative 1, and negative 1 and 1. Yeah. Okay, good job. Thank you very much, sis. All right, then. How do you make 1 here? Yeah. Because we have to make identity matrix, right? And how do you make a 0 here, right? Yeah, we can make a 0 by that. What about this one? Yeah.
It's not
We-
possible, is it?
It's not, yeah, it's impossible. It's not, so it's not possible. It's impossible, right? Yeah, thank you very much. So it's impossible to make, we get identity matrix there, right? So, so we cannot make A is invertible. There is no inverse. Impossible. To complete the form IB by the definition, right? Because they said that if we cannot complete the form, then there is no inverse. A is not thus. A is not invertible. Okay, very good. All right. Almost time, so let me see. I want to do just theorem because we don't have much time left. So let us do this. So we have theorem 2.7.1 inverse of transposes and product and product. Okay, so let A be and a sub y for I equal to 1 through k be n by n matrices. Okay, number 1. If A is an invertible, matrix, then transpose of A. So we read it this way. Outside the first, inverse of transpose of A. All right? Equal to transpose of inverse of A, right? We read it this way. Okay, let me prove this one later. And second one, if A and B are invertible, matrices, then AB is invertible, and inverse of AB, which is B inverse of A inverse, right? So this is similar with the transpose. We have a transpose, then B transpose, A transpose, right? Okay, now we have number 3. If A sub 1, A sub 2, A sub K are invertible, then the product A sub 1, A sub K2, A sub K is invertible, and A sub 1, no, it's a product. A2, AK inverse equal to, yeah, we have a different order, right? So look, we have A inverse of AB, then this one inverse, and then this one inverse, right? So we are using this inverse first, then this, and that, this, right? Okay, so we're gonna have that A sub K inverse, A sub K minus 1 inverse, then A sub 2 inverse, A sub 1 inverse, all right? Okay, we have one more theorem. Two 2.7.2 properties of inverse. So let A be an n by n matrix, and I is identity matrix. Okay, now I want to denote this one. I is invertible, and this one is the same as that. Second one, if A is invertible, then so is inverse of A, and okay, inverse of A equal to A, right? You can say that. Third one, if A is invertible, then so is A sub K is a power, right? A to the second power, A to the third power, like that, right? So, and A to the K inverse is the same as, we can say that this way, all right? Okay, I think that is okay. But the last one, let me write down. I cannot just map there. The A is invertible, and P is non-zero. Real number. Thank you, direct message. Then PA is invertible, and inverse. Inverse of PA is the same as 1 over P, A inverse. Okay, so because P is a real number, right? Okay, we talk about the inverse, right? If we have a number 5, right? Then we can express multiplication inverse. That's the one, right? Because this one is the same as a 5 over 5, right? Yeah. So if a number, we can express it this way. Make sense? All right. Thank you. Okay, so let me prove. Maybe you stay here 10 minutes, 7 minutes. All right. Okay. Just first one. This one. Still 7 more minutes. Copy. I love a proof. Okay, so let us do that. We have this. So we read from right outer to inner. Or we can say that the right to left. Okay, so transpose of inverse of A, right? Okay, that is transpose A. So from right to left, transpose of A, product with transpose of inverse of A, right? Okay, so this one, we can express transpose, we can make associative with this one like this. Yeah, actually associated is we have type 3, right? Okay, we can make it this way, right? All right, then what is this? This is identity. What's the transpose of identity? Same, right? Identity. Okay, now let us show that whether this one, we did this one, whether this one get identity, right? Because I showed this one is identity. So this will be left. We read outer, so inverse. Oh, so I show, yeah, I did not show this one, right? I show this one is identity, right? We have this one, right? So inverse of transpose of A, and then we're gonna multiply with transpose A in here, like this one here, right? So let me do it. Okay, so this one, wait a minute. I'm gonna say this one too. I want to use the same one, but just change the order. So I want to use that like this. Okay, now same concept, same process, right? Yes. So thank you, the message. So we have a transpose, then we make that, and that's the I, right? So transpose of I, which is I, same thing. All right, so like this. Okay, now, so we can just conclude, right? So we have since this one, we get the identity. Also this one identity. It's like this, we have A inverse of A equal to identity, and inverse of A equal to identity, right? Okay. Yes, then we can say that A equal to inverse of A, right? So we say that we read outer inverse of transpose A equal to, and outer transpose of inverse equal to, right? They are equal to each other. Okay. Ooh. Okay, just a little bit more. Number 2, rushing. I don't know. Hold on 1 second. Hold on. Just a little bit more. Yeah. Just 5 minutes more, please. Sorry about that. Oh, see, rushing, then I have no idea right now. Okay. Copy? Okay, proof. All right, so we're gonna show that. So AB times inverse of that equal to identity, because we know that AB invert, oh, we're gonna show that, right? We're gonna show that AB inverse of AB equal to B inverse, A inverse. So think about this, we have a C and C inverse equal to identity, right? Okay, so let us do this. All right, so let's see that. We have let, if we have AB and B inverse, A inverse, so inverse of A, inverse of B equal to, okay, associative A, B inverse, and inverse of A, right? Okay. I know. Thank you so much. Oh my gosh. I'm so crazy right now. Okay, then we notice that I'm sweating, right? Okay, then what do you get? So this means A and inverse of it, right? So we get the identity, right? Okay, now, so we're gonna show that inverse of B, inverse of A, and AB. So it's like this. Inverse of C equal to identity, right? Okay. So show this identity. So we do inverse of B, inverse of A, AB equal to same processing, yes. So inverse of B and A inverse of A, B, which is inverse of A and identity. Okay, done. All right. B, which is inverse of B and B, which is identity, right? Okay, now, so look, we can say that AB, then AB, that is, we can express like AB inverse, all right? So there will be so B inverse A inverse equal to AB inverse. All right. Okay. Thank you for coming. You have a nice evening. Thank you very much.